Hey everybody, Mr. Judson here. So in calculus, we start off by just kind of going back and reviewing, some of the things that we learned in pre-calculus. And if you look at some of these equations here, I think one thing that should happen is we should all feel like we kind of have an idea of what each of these would look like if we had to graph these equations. Okay? It doesn't matter where they are on the coordinate system, but what would they look like? And so real quick, you can go ahead and pause the video. Remember, each time I ask you guys to do something, you hit pause, because I'm not going to wait for 30 seconds of airtime. I'll just wait about 5 seconds and start in again. So hit the pause button while you're watching this, and just draw a quick sketch of what each of these would look like. Okay? You guys go ahead and try it. All right, so if I was going to graph these functions right here, I'd look at this and say, well, y equals mx plus b. That's just a line. So here's my xy axis, and the graph looks something like that. Okay. Here, if I had an xy axis, I know that anytime I see an exponent of 2, then I'm going to see some type of parabola. Absolute value function. Here's my xy axis, and it's going to look something like that. I don't know exactly where it's at, but it'll look something like that. It'll be a V-shaped graph. What does a square root function look like? Well, if I graph that, it's going to have a starting point, and it's going to go off in some direction, kind of like that. Could go off to the left, could go down to the left. Depends on what these numbers are. If I have a cubic function, I know that those look like this. And then this is our rational function. When I graph that, I know I've got a set of asymptotes. And there's going to be two curves that look something like that. Okay? Get close to the asymptotes without touching. Now, when we did this last year, we put A, B, C, D. I think just for review purposes, they're just going to put numbers here and here. They're not going to do anything else. They might put a negative sign out in front. What would a negative sign out in front do to all of these graphs? Should just take it and flip it across the x-axis, right? So if we saw that negative sign, we would just know that. First thing we'd think is, oh, it gets flipped over. Negative a comma b, that's an important point in all of these graphs. So for example, right here, it's the vertex. Same thing here, vertex. Here it's our starting point. Here we said it's our point of inflection. Negative a comma b. Remember, we're doing the opposite of what we see inside the grouping symbols and just leaving this the way it is. For this problem, it's where the center of the asymptotes is located. So that point is at negative a comma b. But all of these right here, they're all going to be negative a comma b. Okay? So what if I asked you guys to graph something like this? F of x equals a negative x minus 2 raised to the third power plus 4. Okay? Go ahead and draw a quick sketch of that. So the moment I see that negative sign, I know that I'm graphing a cubic function that's been flipped over. So when I look at this right here, I'm just thinking, flip that thing over. And that point of inflection, that's where the direction that this is curving changes and goes the other direction, is going to be at 2 comma 4. So 2 comma 4, that's this point right here. I got to flip it over. And so there's a sketch of what this graph would look like. So they're going to ask us to do some of these today in our book. And what they're looking for is just a real simple sketch about what does it look like and where is it located. Let's try another one here. Let's say I've got f of x equals a negative x plus 3 plus 2, and we're going to square that. Real quick sketch. All right, so this time I know I've got a parabola. It's been flipped upside down, and the vertex is going to be at negative 3 comma 2. So negative 3 comma 2, that's right about there. I want to flip it over. Now, one thing we remember from last year is that when you move away from the vertex, however far you go, you've got to go down that distance squared. So 1 unit over, 1 squared, that's 1. If I go 2 units over, 2 squared is 4, so 1, 2, 3, 4, I get a point right here. And then I've got symmetry on the other side. And there's my parabola. Now if I have some other numbers in front of the parentheses or here, that's going to change things up. We're not too worried about that. I think what our book is looking for in this first section is, do we understand the basic functions, and can we produce a graph if the numbers don't get too messy? You know, what would I do if there was a 2 right here? Well, I'd go down twice as far as what's normal. What if there was a fraction here, like 1/2? Well, then I'd go down half as far as what's normal. And so that would make my parabola get a little bit wider. We're not going down as fast. All right, so that's the first thing they're going to ask us to do. All right, so the other thing they're going to ask us to do today is to be able to find the intercepts for a function. And we know when we look for intercepts, there are X-intercepts and there are going to be some Y-intercepts. So what are those? An X-intercept would be anywhere where we cross the x-axis. And what all these points have in common is their y-coordinate is always going to be 0. So this would be where y equals 0. So how would I find the x-intercept? I'm going to set y equal to 0, and then I'm going to solve for x. What about a y-intercept? Well, that means we're on the y-axis, and every one of these points is always 0 comma something. And so what we're saying is that's where x equals 0. So an x-intercept is where y equals 0, a y-intercept is where x equals 0. We've got to think opposite, okay? And so here, we just want to plug in a 0 for x. And then we'll just do the math and see what y is equal to. So let's do a practice problem. All right, so we want to find the intercepts for this equation right here, y equals x squared minus 5x minus 14. Okay? And remember, intercepts, that means both x and y intercepts. You guys go ahead and try it. All right, so if I want to find the y-intercept first, I'm going to let x equal 0, which means when I plug that in, I'm just going to get y equals a negative 14. So my y-intercept is going to be at 0 comma negative 14. X-intercepts, I want to let y equal 0. So if I put a 0 right here, that means now I have to solve that equation. So I'm gonna try and factor this. If it doesn't factor, then I've got to use the quadratic formula. Fortunately, I think this one does. So if I factor this, I've got x minus 7 times x plus 2. Negative 7x plus 2x, that does give me that middle term. And so that means that x is going to equal the opposite of what we see here, 7 or negative 2. So that means that my x-intercepts are going to be at 7 comma 0, because remember we're saying y equals 0 here, and negative 2 comma 0. Now, if I was asked to graph this function, I would look at that and say, okay, let's make a quick graph. I need to go down quite a ways because I'm going to hit 0 comma negative 14. So I'm just going to say, let's count by 5s. So there's 5, 10, 15. I'm going to have a point that is right about here. And I'll count by 5s on the x-axis as well. And I want to cross the x-axis at 7 and negative 2. So remember, not here, that's negative 10. This is negative 5, so somewhere right about there. And I'm crossing at 7. If this is 5, we're just a little bit past that. And I know that this thing looks like a parabola. Okay? Now, that point right there is not the vertex. The vertex has to be halfway between those. So if I drew an axis of symmetry, my vertex would have to be somewhere on that dotted line. So to graph it, I'm just going to say that this graph looks about like this. Where is the vertex? Well, I don't know. That would be a different problem. But for right now, this question really just asked me to find the intercepts. I found those, and I showed those intercepts on a graph. It might be a good idea to go ahead and label these. 0 comma negative 14. This right here is negative 2 comma 0 and 7 comma 0. There we go. Let's try another one. All right, so again, we're trying to find the intercepts. Our equation is y equals x minus 1, that quantity, times the square root of x squared plus 1. You guys go ahead and try them. See if you can find those intercepts. All right, so if I was going to find the x-intercept first, I know that happens where y equals 0. So 0 equals x minus 1 times the square root of x squared plus 1. And so if I'm going to multiply two things and get 0 for an answer, either this has to equal 0 or that has to equal 0. Well, that'll equal 0 if x equals 1. Could we make that equal 0? I don't think so. If I'm going to square a number, no matter what I put in here, at the very least it's going to be 0. If I put a negative number and then square it, it's positive. And I'm going to add 1 to it, it's just going to get larger. So we can't make that equal 0. So this would be our only x-intercept at 1 comma 0. My y-intercept, remember that's where x equals 0. So we just have to plug in a 0 here and here. And what I get is y equals a negative 1 times the square root of 1. Which that's just a negative 1 times a positive 1. That's negative 1. So my y-intercept is at 0 comma negative 1. Now if I had to graph this, that's a whole different problem because I don't recognize this as one of our main graphs that we talked about last year. Doesn't mean you can't graph it. It doesn't mean there isn't a graph, but it's going to take a little more work. I know it's going through these 2 points. It's not undefined anywhere, so there's no asymptotes in there. But there's going to be some kind of curve that would match this. And I would either have to plot lots of points or go to the graphing calculator to see what that looks like. All right, let's try one more. All right, so this time I've got y equals, these are getting a little messier, y equals x squared plus 3x over the quantity 3x plus 1 squared. You want to try and find those intercepts. Don't forget, once I give you guys the problem, hit the pause button on the video, work it out on your own. You know, don't go, oh, Judson's already doing it. Well, shoot, there goes my opportunity. No, you're going to hit the pause button. And the reason I'm doing that is because these videos take up a lot of memory. And it's just more work to get those loaded up onto YouTube. Okay, so go ahead and hit the pause and give that a shot. All right, so I'm going to find the X-intercept first. So that would happen wherever y equals 0, which means I really want to solve this equation. Well, if you remember this from last year, the only way a fraction can equal 0 is if the numerator equals 0. Right? We don't want the denominator to equal 0. I don't ever want this to equal 0. Remember the domain? Denominators cannot equal 0, period. There's never a time when that's okay. Well, although we're going to deal with that a little bit this year. Remember I said every time I tell you something, I'm going to turn around later and tell you I was lying? Well, I'm not really lying. It cannot equal 0, but we can get really close to 0. We might be interested in what happens. That's coming later, all right? So the only way this equals 0 is if the numerator equals 0, which means really I could just get rid of that. It's almost like if I took that denominator to the other side and multiplied, 0 times anything is 0. And now if I try and factor this, I'll factor out an x. And so that means that x has to equal 0 or -3. That's where we're crossing the x-axis. So my x-intercepts are going to be at 0, 0 and -3, 0. So one thing that's kind of important here is when they ask us to find the intercepts, these are points on the graph. I don't want to stop here because that's not a point. That's just two numbers that you can plug into here to make it equal 0. I want to make sure my final answer is written as points, okay? All right, and my y-intercept, if I plug in a 0 for x, I'm going to get 0 plus 0. 3 times 0 is 0. So y is going to equal 0 over, if I put a 0 here, I get 0 plus 1 squared, which is 1, and that equals 0. So my y-intercept is 0, 0. And we already knew that because if I'm hitting the origin, that's both an x-intercept and a y-intercept. Right? You can't hit the x-axis at 0 and not hit the y-axis at 0 at the same time. So there it is. There are my intercepts. Now again, what does this graph look like? I have no idea. Never graphed anything like that before. I'd either have to plug in lots of points or look at my graphing calculator to see what that looks like. All right, in our book, they're also going to ask us to check for symmetry. This is something that I rarely do when I'm graphing. It's if you know it and understand it, it can be helpful. But if I ever forget about it, it's not that big of a deal because I can use a graphing calculator to figure it out. To check for symmetry, all they really mean is if I put a negative x in place of these x's, do I get the exact same function? So in other words, let me do this in a different color. I'm going to put in a negative x squared plus 3 times negative x. And I'll put a negative x there, 3 times negative x plus 1, oops, need a parenthesis there, and then I need to square that. If that produces the exact same equation that I started with, then what we have is symmetry with respect to the y-axis. It's going to be the same on both sides. Okay? Well, let's find out. Negative times a negative is a positive, so that'd be x squared. Looks good so far. Positive times a negative, that's negative. That's not the same thing that I have here. And then here I've got a negative 3x plus 1 squared. No, there's some differences there. It's not the same equation. So this would not have symmetry with respect to the y-axis. If I did get the exact same thing here, the only thing that tells me is whatever it looks like on that side, it's going to look the same on this side. I'm still not sure what the graph looks like. Okay? I think I need my graphing calculator to help me out here. So I'm not real concerned about the symmetry part. I do want to make sure we know how to find intercepts, both on the x-axis and the y-axis. And if we can recognize functions and we can find intercepts, I think we're doing okay here. All right? So that's it. That's not a bad day. That's what I got for you today. Let me get you guys an assignment. All right, so here's what we have for today. It's assignment number 1, our first assignment of the year. It's on page 8 of our calculus book. We're going to do 19 to 25 odd and 39 to 55 odd. What I'll do is, if someone's still struggling with the book, I will include this page on my Sway page. I'll just make a real quick PDF copy of that one page with the homework problems, and then you can go ahead and do that. Okay? All right, that's it. We're only going to do 2 assignments this week. So 1 today, 1 on Thursday. Next week, hopefully, we can wrap it up to 3, but we'll see. We're going to have to see how things are going. I don't want to push us too far if we're not ready for it. All right? So, I'll see you guys Thursday.